Now, what do we mean by the discriminant of a quadratic curve? Well, if we have ax squared plus bx plus c, right, which is a pretty standard way to represent a quadratic curve, right? If we take from this formula, we write b squared minus 4ac, that this here is referred to as the discriminant, right, of that quadratic curve. And it basically tells us what we call the nature of the roots. All right. And so we have three possibilities for the discriminant. We can have when b squared minus 4ac is greater than 0. In this case, we have two real distinct roots, so they're different from each other. All right. And then we have b squared minus 4ac is equal to 0. This is where we have two real equal roots, right? And then finally, b squared minus 4ac is less than 0. This is where we have two imaginary roots, right? And so when we say real and distinct, this means that the two roots, which are the x-intercepts, basically where the quadratic cuts the x-axis, right, we'll have two different values, right? So for example, you might have, x is equal to 1 and x is equal to 3, right? Whereas for b squared minus 4ac is equal to 0, you can have two equal ones, right? We'll have two equal ones. So you'll have x is equal to 4 and x is equal to 4, right? So really one solution. Whereas for the two imaginary ones, well, you will have no solution, right? No real solution when we do our quadratic formula, for example.